For our project, we decided to calculate the coefficient of friction for 4 different surfaces. We slid a block down an inclined plane and recorded the time it took to get to the bottom. We used this data to do a thorough analysis of the forces acting on the block. We used a board of length 1.27 meters that made a 36.87 degree angle with the ground. The block we slid down was 2.44 kilograms. In this problem, we're looking through a dynamics lens. To begin, we draw all the forces acting on the block. This includes gravity going straight down, the normal force perpendicular to the surface, and the frictional force going in the opposite direction of motion. We separate the force of gravity into the x and y components in order to calculate the normal force and set up the equation to find friction. The force of gravity is mass times the acceleration due to gravity, so we get that the force of gravity is 24.4 newtons. We find that the force of gravity in the y direction is 14.34 newtons, and in the x direction it's 19.74 newtons. We know that the vector sum of the forces in the y direction is equal to 0 because the block is not accelerating in that direction. Therefore, you can set the sum of the forces equal to the normal force plus the force of gravity in the y direction, which is equal to 0. We find that the normal force is 14.34 newtons. This gives us all the information we need to find the coefficient of friction for each different surface. The first surface we slid the block down was a rug. The change in time was 1.4 seconds. We can use this to find the average velocity of the block to find the acceleration. We find that the velocity is 0.91 meters per second and the acceleration is 0.65 meters per second squared. We know that since the block is accelerating, the vector sum of the forces is equal to mass times acceleration. We can plug in the x component of the force of gravity, the mass, and the acceleration into the equation to solve for the force of friction, which we find is equal to 18.16 newtons. We know that the force of friction equals the coefficient of friction times the normal force, so we can plug in for the force of friction and the normal force to solve for the coefficient of friction, which we find to be equal to 1.27. The second surface was a tarp. The change in time was 0.95 seconds, so the average velocity was 1.38 meters per second and the acceleration was 1.45 meters per second squared. This gives us a force of friction of 16.02 newtons and a coefficient of friction of 1.13. The third surface was plexiglass. The change in time was 1.6 seconds, so the average velocity was 0.79 meters per second and the acceleration was 0.49 meters per second squared. This gave us a force of friction of 18.53 newtons and a coefficient of friction of 1.29. Our fourth surface was wood. The change in time was 1.4 seconds, which was the same change in time from our first surface, so we got the same results and same coefficient of friction. You may have noticed that all our coefficients of friction were greater than 1. This means that the frictional force is greater than the normal force, which is not possible in a perfect physics world. This could be due to other factors that we have not yet learned about, such as sound, air resistance, or other things.